All right, guys. This is sort of what it takes to get used to these equations, and I like to do this kind of thing because very often I can't get an accurate idea just asking if everybody's okay, if you're actually okay with something. Because for some reason people just don't want to let me know that they're not okay with something. That doesn't make any sense to me. So now I know that there's some more work to be done, which is fine. It takes this kind of thing. It takes you to try something, and then we talk about how certain things work, and then you try it again, and it slowly kind of gets better and better and better. Right? So everybody's tried most of these out. So really, one of the most important parts of solving equations, just to even be able to start trying to do them, is to fully understand like terms. Right? So I'm not calling anybody out, but I saw several people, and I helped them when they said 5 plus 2x was 7x. So if you did that, don't think it was just you. Right? Where did that come from, and why is that not right?
Because they are not like terms.
Yeah, they said 5 plus 2, and they said, well, that's 7. Come on, Jeff, I know that's 7, but it's not right because I've got 2 x's and 5 1's. So if you're telling me you got 7 x's in there somewhere, I'm like, what the hell is that? I don't see 7 x's. I only see 2 x's in there. So as far as simplification, as far as consolidating like terms, that's been done. It's all done. There's nothing I can do on either side. That's when I start moving stuff. So that's one reason why understanding like terms is really important, because you have to know at what point do you start to subtract 5 and add x and whatever, right? You start doing that when there's no more like terms left on either side. And if you think there's too many like terms, you're always going to end up with really funky answers. So there's no like terms. Obviously this side there's barely anything. These aren't like terms, so now I just start to say, who's on the wrong side? Yeah, because the x's are all together. They've established they're on this side, so he's got to get the hell out of it. So how do I kill him? I like it. Because it's positive 5. Not because it's a plus, but because it's positive 5 plus 2x. I'm going to subtract 5. So that goes away. 2x equals negative 2. I like it. And then, of course, the last step is almost always division. Right? Whatever's with the x, divide by it. 2 divided by 2 is 1. Nobody killed the negative, so it's still there. Is that cool? Okay. Now, to check this, throw back in there 5 plus twice negative 1, so we're going to check that answer. 5, 2 times negative 1?
Negative.
Equals 3. Check. That works. All right. Nice little quick check. How do we feel about that? And I like the fact that most of you guys are at least trying to keep things organized. And that's one of the main places where people screw themselves over. Even if you understand how to do it, if you don't keep things organized, you're going to, at some point, you're going to screw yourself up. And I hate people losing points because they just forgot where things were. There's no need to do that. Just keep yourself organized. And that's coming from somebody who in general is not that organized. I think you can tell from how I normally am up with a board. But I know the importance of being organized here, so that's why I am. Okay. So here we had some trouble, the same trouble, and I don't blame you at all because this is something very foreign, but I think I've managed to convince a lot of you guys about this. I had, understandably, don't write this down. I had people asking me, when you see this, does the 2 just go through? And the short answer is it could, But why do that to yourself? Because then you have to remember this. If you just took the 2 through, you have to remember the negative is still out there. So 2 times 2x, 2 times negative 5. But then you still have to bring the negative through. That minus is still out there. And then I have people say, and again, I'm not knocking you. This is true. That is a subtraction sign, but a subtraction sign is the same damn thing as a negative sign. It really is. And we know that. If I saw negative 2 plus 7, what kind of sign is that? Negative sign. How can I rewrite this? 7
Minus 2.
So a subtraction sign, right? So the subtraction sign is a negative sign. They actually are the same thing. And more directly, can I rewrite minus as plus a negative?
Yes.
So then it is a negative 2 that I'm pulling through there, right? It's one of the easiest things to forget, though, is to bring that minus sign through. And then you get funky-ass answers sometimes. But I don't intend to make it funky. So here I'm going to pull the negative 2 through because I got to distribute first. So the 3x is still there. Negative 2 times 2x. Minus 4x. Negative 2 times negative 5. And here's another. So a positive sign is the same thing as sum, a plus sign, right? So when I say to myself positive 10, that's exactly what I write. So I don't think it's multiplication or something. Subtraction cannot become multiplication. I'm going to say that so you go insane with it, if you haven't already. So step 1, distribute where you can. Step 2, consolidate. Like terms, each side. One side's just 21. He's cool. The other side, you can go drink. The other side,
Negative x.
yeah, good. And be real careful. I want to make a big point of this because this, I've over the years I've seen this more and more and more. And again, please don't think I'm picking on you because several people are doing this. You can see why somebody might do this. You see why they might think that way. But when do I use this kind of process? When I want to make something go over here. That's the only way to legally make it go to the other side. Because never forget what's really going on here. Never forget what's really going on here. If I subtract 2 here, the only way to make it still true is to subtract 2 over there. I mean, that's the bottom line. That's the only reason we ever do that. If they're already on the same side, it would definitely freak me the hell out if we did this. Because now I get 3 equals 7. That doesn't maintain it, right? So just remember, what are variables? I like the letters, but what do they represent?
They're unknown.
The unknown.
Unknown numbers. So they have to act exactly the same way as numbers do. This is actually a more important statement than you realize right now. Just always remember, anything with variables in it has to act just like a number does. Because that's what they are. I just don't know what they are. Why are they harder to work with, though? Because I don't know what parts of them are. So they're harder to work with, but they got to work the same way. Because that's what they're numbers. Okay. So I can't do that. They're already on the same side, so I just put them together. 3x minus 4x.
Negative x.
Good, negative x. And that's, of course, a really easy place to say 1, but you just got to catch your brain and say the negative is bigger. So you start to see the pattern. Distribute, consolidate, and once you've gotten everything together you can, you start moving stuff. Whoever's in the wrong place. You make it cancel and effectively move to the other side. Who's in the wrong place? 10. So what do I do?
Minus 10.
On both sides of the equals. So whenever I say both sides, I inherently mean of the equal sign. So it cancels there.
11.
And you certainly cannot stop there because I haven't gotten to my goal yet. My goal is x equals a number. I'm not there yet. And what's understood to be in front of here?
1.
And sometimes it's not a bad idea to put it there so you can really see what the hell's going on. Because this, if you leave it like this, I saw somebody, and it's exactly what I would have done to the teacher if I was in your place. I was like, well, then what the hell's that?
Yeah.
Right? And I'm like, no, it's not that because it's understood to be a 1. So pull that back in if you need to. Right? So you're going to divide by what's there, which is negative 1. And that looks a little better. So anything that's understood to be there, we can put it there anytime it makes it easier for us. Because it doesn't change it. It's understood to be there. So if you want that 1 there in front of something, put it there. Who cares? If it makes it look easier, it's fine. And what do you get here?
Minus.
Cool. Right, and you check it. It works. Real quick, I want to show you something kind of weird right here. Don't write this down. Just kind of stare at it as I do it. Just humor me for a second. Remember how I said I don't like negatives? Because it's a place where we can mess up, and you can see that's true. Zeros and negatives always find a way to mess us up. So watch this. This is weird. This goes against my steps, but it's not illegal. I'm going to add x. Right? X is not in the wrong place. Why would I do that? Well, I can if I want to. I can add whatever the hell I want to both sides. And I'm going to do that because it's going to make the x. Let me put it this way it is. Now the x is positive. Now, real careful. I am not saying you have to start doing this. I'm not saying this is a better way to do it. It actually adds a step on.
Yeah.
But I want to show you why that answer makes sense in a different way. What do you do next? Who's in the wrong place?
21.
So then you have to subtract 21, and now you do get more directly
Yeah,
negative 11. Right? So that's when that last step is divide by a negative. It's actually telling you, oh yeah, you could have put it on the other side and they would have become negative over there, but you do it at the end. Who cares? You with me? That's why I said if you have a choice at some point to move x's one way or the other, you move in the way that keeps them positive so you don't make some mistake at the end.
So I can leave it like negative 11 for x, or I have to...
No, this is beautiful, or if you want to, you can turn it around. They both say the same thing. Yeah, the x doesn't have to be on that side. It's just we normally like to see it on that side. So you can turn that around if you want to. Cool. It's actually called the reflexive property. There's a property for that. You can turn it around. Does this check? Did you guys check it?
I don't know what was harder, doing the problem or checking.
Oh yeah? Let's try to check it.
Yeah.
So I'm having trouble spelling check. So checking negative 11. So I'm going to throw a negative 11 in wherever I see an x. That does look disgusting. Yeah. So we got this here. Alright, I'm going to take this as a yes.
You told us not to write it down.
Oh, good. Just have you stopped? Have you done staring at it? Alright. So what do I do first in here? Yeah, it's order operations now. I could distribute the negative 2, but that would be so freaky right now. I so don't have to do that because I can do the inside, right? So what's 3 times negative 11?
Negative 33,
Minus 2 times...
22, negative 22.
Good, negative 22 minus 5. Are you guys with me? And we want to see if that's 21. So negative 33 minus twice. What are you getting here?
27, negative 27.
Good, they're both negative, so you add them. Put the sign back on. Not going to do negative 35?
No.
Hell no, why not? You don't subtract before you...
Multiply.
And that's so easy to do now, but remember, order operation's always there. I don't care what section you're in. So you got to bring the negative 2. What's negative 2 times negative 27?
34. 54.
54? Good. And sure enough, negative 33 plus 54 is 21. So I agree, that was not the easiest check in the world. But when you're allowed to use nothing but numbers, I desperately want that to be a situation where I know there's a lot going on, but there's no variables in there. I should be able to just latch onto this. I should be able to chunk it down slowly. I should be able to do it.
Keeping track of what you're doing is hard. Bringing everything down.
I know. Yeah. So that's when that's a natural motivation to learn how to do several things at once. So you don't have to do every single step. Okay, what about the next one?
Question.
Yeah.
Can we just multiply instead of divide like negative 1?
Yeah, sure.
Because
Sure.
if you divide negative 1x with 1, it'll be like the answer is going to be negative x. right?
Do it
It'll
again.
be like if you divide negative x by -1, the answer might be okay. So yeah.
So you can actually multiply by -1 here also, because either thing you do cancels that negative out. Yeah. And think about it. If you just step out of the math for a second, what number, the opposite of it is 11? -11. So it makes sense the answer is -11, right? So sometimes we get so, you guys, what does this really say? The opposite of what number is 11? Well, the opposite of -11 is 11. So it makes sense the answer is -11.
What happened to that imaginary one?
It's still there. It's not imaginary, it's just understood. Cool. Okay. Where are we at? Number 3? So a lot of you guys had fun with this one. And it's loaded. And when you first look at it, you might set yourself up for difficult times because you're like, there's so much shit in there. But I'm with you. But what you do for yourself, and I was actually trying to do this for some people, it's hard to do on the board, as it would be, but you just cover everything else that doesn't matter at the moment. That's what I was saying last time. The people that are really good at math naturally are the people that are able to say, all this other shit doesn't matter. All I care about right now is distributing the 5. That's all I care about. So if you can't naturally do that, which is not your fault, obviously, it's just, we're all hardwired differently, just cover all the other shit. Now, and then you pull it off and bring everything down with you. Don't forget everything, right? But that just helps you focus. If I gave you just this on a test, you should say, oh, yeah, give me more of that, right? That's the first problem in here. So it's just as easy, even if it's surrounded by all this other stuff. So I don't know, that's the first thing your eyes should be drawn to the parentheses, and there are actually parentheses here too. What happens up here?
Positive.
Good, so that's 3 plus 5.
8.
Is everybody cool with that? Be really careful. I saw a lot of 15s. And you can see where that comes from. People say, all right, negative times negative is positive. But no, because negative times negative is positive. Positive is a plus sign, right? You gotta be careful about that. What's up?
Me?
Yeah,
No.
you're right. Okay. You just got this whole, I'm stressed out. Anything else about that before I keep going? Yeah.
So, please excuse my dear Aunt Sally. It's safe to say that in situations like this particular properties come first, and then you can.
Yeah. And I am doing this before that or at the same time, but it's separated by a plus sign, so it's fine. The more you do it, the more you realize you can do several things at once. You with me? So I don't have to necessarily focus just on, I could do this and then do this, so it saves me some time. Whoever was saying earlier, I don't want to rewrite the whole, I'm like, I don't want to either. Should. Right? I want to do several things at once.
Multitask.
So what do you do here?
Plus
10.
10.
5 times 2 is 10.
Minus 10.
And notice, I don't need the parentheses anymore. They were just there because it was showing me I was multiplying 5 times something. When I do that multiplication, I don't need them anymore. Don't put them there because that actually messes you up. So that's there. What do I do on this side? This is 2, right?
No.
See, you fell in my trap. I'm evil. Can't do that. Can't do the subtraction until you've done this multiplication, right? So the x and the 4 are still there. Negative 2 times x. Negative 2x.
Plus 14.
Plus 14.
Yeah, negative times negative is plus 14. So it's kind of funny if you really think about it. Somebody said something earlier. If I see negative 2 times x, what is negative 2 times x? when we write it, we're effectively saying, I don't have a freaking clue. It's negative 2 times x. Do you guys, that's what that means. When I see something next to something, that's times. So when I go, what's negative 2 times x? We have no idea, Jeff. Negative 2x. And that's because that means multiplication. Does that make sense?
Yeah.
So there's nothing to consider there. You're really just writing it as it is. Negative 2 times x, negative 2x. I don't know what the hell it is. So just put that down there just like that. Now what can I do on this side?
15.
Good. These are like terms.
18.
Stay with me now. Right, so 18 and 10x is still there. Yeah, good. X minus 2x minus x. 4 plus 14.
18.
All right, and the next step is where people started to freak out. What can you do there?
You can add it.
Yeah, this is one reason why I always move my variables first before the numbers. It's because if you subtract the 18s, you get here and the people do really weird things with this. Well, if you subtracted the 18s, have I got my x's together yet?
No.
So then you'd have to like add the x. You haven't finished yet. Don't start trying to divide or weird shit. You just haven't moved your x's over yet. So if I do this, I get here. Oops.
Something went wrong.
And then add x. Because I got my numbers together. They just happened to cancel. I haven't gotten my x's together yet. Now I am getting my x's together. What's here? 0.
9x.
Good. Negative 10 somethings plus 1 something is negative 9 somethings. And then maybe if you got there, now some of you guys probably got there the other way. Maybe you added 10 or something first, and then you killed the 18s. This is another place where people start to freak out a little bit. But step outside the math for a second. What does this really say? Negative 9 times a number is 0. What's the answer got to be? Yeah, the only number I can multiply by to get 0 is 0. So I should expect that answer, not undefined, not no solution. What do I officially do though?
You divide?
Divide.
Yeah, divide by negative 9. I don't let this side tell me what to do. If it was negative 9x equals 18, we would have no trouble saying, oh, I divide by negative 9, I want to kill the negative 9. It doesn't matter what's here. All I care about is why is my x not by itself yet? That's there. Get rid of it. X equals 0 divided by anything? 0.
So that was right.
Yeah, x is 0. Cool. Which doesn't mean no solution. It doesn't mean weirdness. It means the answer is 0. Right? How much money did we make this year? 0. Yay, we didn't lose money. Yay. Right? There could be some company out there. Nowadays, 0 is good. To check this, you check it the same way you always do. So you get 3 minus negative 5. Now, the big thing about checking is you always go back to the very first. If you go on the second step or the third step, you could have made a mistake in there somewhere. So your number might work in that equation, but you made a mistake before that. It would never work in the actual first problem. You with me? You have to always check it in the original problem. So now in place of x, I put 0. Equals 0 plus 4 minus twice 0 minus 7. Just put a 0 everywhere there's an x. So I get 8 plus 5 times...
2 minus 0.
Good, 2 minus 0, so 5 times 2
2.
equals 4 minus twice
14. Negative.
negative 7. Are you guys with me? 2 times 0 is 0. Take away from 2 is 2. 0 minus 7 is negative 7. Is that cool? So over here I get 8 plus 10 equals...
4 plus...
Good.
4.
Negative 2 times negative 7.
14.
14. So I get 18 equals 18. Check. Does not mean the answer is 18. All I care about here is it's a true statement. Doesn't matter what the number is. That means that my 0 is the right answer. Cool. You guys with me? No? What's up? Be honest. If you have an issue, at least 8 other people have an issue with it. Yeah.
I see how you got 18, you did 4 plus 14. What happened to the negative 2x?
Oh, x minus 2x is negative x. Right? 1 something minus 2 somethings is negative 1 something. If I have a buck and I owe you 2, I can give you my dollar and I still owe you 1, negative 1. Yeah. Okay. Yeah.
What do you do with that 8
Where are we at?
in the beginning when you check? Well, yeah, that 8 right there altogether is still 5. Isn't it?
So if I have 3 minus negative 5, what's negative times negative?
Positive.
Plus. So I got 3 plus 5. It cannot become multiplication, right? It cannot. Subtraction is addition. Subtraction of a negative is the same thing as addition. Forgiving a debt, right? So the bank took $5 out of my bank account. I'm at 3, and they're like, "Oh, we made a mistake. Let's put the $5 in. Now I'm at 8, please." Forgiving a mistake should make it go up. Should become plus. Okay, maybe. So what about number 4? Four looks freaky. But let me ask you something. If I saw this, what's the thing that I'm not going to do a damn thing with until the end? I love it. 4x. Right? All the x's are together. I'm not going to do anything until the numbers figure themselves out and get the hell away from me, right? So that 4x is just going to kind of... So this is the same way. Wherever my variable is, it's going to stay that way till the end. The last thing I almost always do is multiply or divide. Divide or multiply. Exactly. I'm trying to make my point. So in this case, the last thing I would do is divide the 4 away. Here, the last thing we're going to do is multiply that 4 away. I just haven't got all my numbers together yet. So what happens on this side? 2 minus 5 is
Minus 3.
minus a negative.
Plus 7.
Plus? Negative 3 plus 7?
Negative
4.
plus 4.
Plus 4? Yeah. Who's in the wrong place?
5.
Yeah, the 5 is over there with the x. So subtract the 5 away. 4 minus 5, negative 1. And we got x over 4.
Multiply.
Good. Multiply. Multiply both sides by 4. 4 times negative 1.
Negative 4.
Negative 4. So again?
She added another step to it, I was trying to figure it out, but I did that one.
But when you check it, it's not 4.
Cool. That's pretty, yeah. So you guys with me? And then if you want to check this, so I think x is negative 4, right? So plug a negative 4 in there. 2 minus 5 plus 7, we basically did that. We know that's 4. 5 plus, what's negative 4 divided by 4?
Negative 1.
Negative 1.
Is 4 equal to 5 plus negative 1?
Yes.
Check. Yeah, so that works. When you're checking, you never do stuff like this. You never move stuff around, because that's assuming that it's true. To check it, I work with one side, the other side, and see if they end up the same. Because if we start moving stuff, you might make the same mistake you made before, possibly, and you might think it's right when actually no, it's not right. Okay. All right. So anything else about that? Last one here. Number 5, the longest one on there. I like it, so I've left myself no room. Okay. So of course your eyes are drawn towards what? Good. So right here.
8. 4 minus 4x.
I like it. 2 times negative 2, negative 4x. And you still have that minus x there.
15 minus 3.
Right. So now on each side, you can start just combining your like terms. So over here I got 6x minus 4x, 2x minus x,
X.
1x. I like it. And you still have your plus 8 there by himself. Over here, negative 3x plus 4x.
Negative 1. Positive x.
Good. That's 4 minus 3, so that's positive x.
Plus 17.
15 and 2,
17.
17. And here's where people, you don't try to think ahead, you just do what you know you have to do. You let whatever's going to happen happen. So you know you've got to move that x. And how do you move it? Minus. So it goes, now it just happens that both sides die. But now you don't circle that. Right?
Oh, isn't that the solution?
Good. If it's not true, it's no solution. This is true when this is true. When is this true? Never. So that's never true. There's no x that can save this thing's s. It's bogus. You with me? So there's no solution.
So there's no check.
There's no check. Nothing works. You could try to check it by just plugging a number in, and seeing that it doesn't work, but you'd have to do that for, that'd be a little too many numbers, right? Yeah.
I got 0 equals 9.
Okay, good. Yeah, you could subtract 8, you get 0 equals 9. The numbers don't matter. It's the idea. Is that true? No. So it's still no solution. However you change your numbers around, it's never going to be a true statement. Is that cool? Yeah.
Over here, since there's no variables on this side, that what you equals over here just continue on the equation, you know what I mean?
Oh, here there's no variables, so it's just a bunch of.
Because I understood it as you gotta keep these sides separate.
Good.
So when you did this equals this, shouldn't it have been 5 equals 5 plus x over 4? Shouldn't you have kept them separate?
What did I not keep separate?
You just did what this.
Good. I did this side, left this side alone. I did this side.
So 2 minus 5 minus negative 7.
I love it.
5.
No. What's the two sides? This is one side. This is the other side. There's the divider. Equal sign splits them into sides. You would never say this equals 5 and that's separate. No.
It looks like that's so you did 2 minus 5, which is negative 3, plus 7. So that shouldn't it be 5 equals
But what's negative 3 plus 7?
5?
No. Negative 3 plus 7 is 4. That's why I put a 4 there. That's all. Okay.
Okay, I didn't see that.
I'm with
Let's
it.
look at x.
But yeah, I could never ignore part of a side. Because what does it take for this side to equal this side? Both of these together have to equal this. So if I leave anything out, it's not necessarily true anymore. This plus this equals this. So I can't just ignore a part of it because then it might not be true anymore, right? Okay. Yeah, so you're right. That one's the only nice thing about that problem is that you get to the end and there's no check to do. Because how can you check no solution? You can't. You have to check every single number in existence. And I don't want to do that. Okay, so let me give you this. And what I want you to do is right now. Next time we're going to start off with any questions about equations. Between now and next Tuesday, you must do whatever you must do to get through the equation homework and to get a better feel for equations. Right? You can come see me in my office hours, you can go see tutors, whatever. At the beginning of next class, we're going to start with some more equation stuff, but then I need to get into word problems. So I am going to give you this handout. If you glance at it and you're like, no, you can just bring it with you next time. But in case you get any time, you want to look at it and see if it sounds at all familiar, that's why I want to give it to you.
So can we turn this in for extra credit?
Same one, yeah. Anyone else need it? You got it? Who needs it here? Anybody needs it? Did everybody get it already? Who needs that? Okay.
You want us to work on this between now and
No.
Just keep it. He just said you can turn it over if you want and ignore it, or you can look at it for next class, or you can save it for next class. You do it in class.
Everybody got that? Yeah, you can go. Good. No. That was there, right? So, right at this point, I'm at -1 equals x divided by 4. So on both sides, I'm going to multiply 4 times that side, 4 times that side. And that's cancel. Because that's multiplication, that's division. You can always think of that as over 1, right?
The last step is always
Or, if you look at the hand, or multiplication. Division happens more often because normally our variable is being multiplied by a coefficient. But sometimes the variable might be divided by something, in which case my last step would be multiplied by 5 to get it. Cool. Oh, yeah.
You have my list.
Yes. Bushra?
Yes.
And what I got? Okay.
That's mine. Is that Rodriguez?
Jose, I'm a little worried because I have lost your. Hold on.
I got it.
Oh, you did. You just never get. Okay.
Lost.
I thought I lost the first part. You just never got.
So then you do it
I
again.
got it.
Then you can do it again. That'd be great. Yeah.
Better grade.
The homework you turn in on the day of the test? Ain't no way in hell I had that graded yet. So you'll get it back eventually. Yes.
When on Tuesday, the homework?
Say again?
Homework on Tuesday? Like I turned in Tuesday last week.
So if you turn it in on the day of the review or the day of the test?
Before that, I turned in the day before. The beginning of the week, we had the test. The review video.
Yeah. So either one of those days, I'll get it back to you eventually.
Okay, Mr. Waller, like you said, if you want to correct it before you turn in, I'm not turning